Aim: A. To perform the following reactions: action of water in quicklime, action of heat on ferrous sulfate crystals, action of copper sulfate solution on iron nails, reaction between sodium sulfate solution and barium chloride solution. B. To classify the above reactions into combination reaction, decomposition reaction, displacement reaction, double displacement reaction. Apparatus and chemicals: porcelain dish, filter papers, dropper, hard glass test tube holder, test tube stand, burner, a pair of forceps and beaker, quicklime, ferrous sulfate crystals, copper sulfate solution, iron nails, sodium sulfate solution, barium chloride solution, dilute hydrochloric acid, water, and litmus papers. Procedure: take a small quantity of quicklime in a porcelain dish. Carefully add a few drops of water of the quicklime with the help of the dropper. Record your observations. Observations. Activities. Observations. Note the evolution or absorption of heat during the reaction by carefully touching the dish. Observations. Porcelain dish becomes hot, indicating that the reaction is exothermic. Activities. Note the evolution of a gas or vapor during the reaction. Observations. Water that was added got converted into steam due to the heat given out. Activities. Note the sound produced, if any, during the reaction. Observations. A hissing sound is produced when water came into contact with quicklime. Activities. Note the physical changes, if any, during the reaction. Observations. Quicklime first swells to a voluminous mass and then crumbles to fine powder. Chemical reaction: CaOS plus H2OL, CaOH2Aq. Conclusion: quicklime combines with water to form conclusion hydroxide. This is an exothermic reaction. A plus B, AB. This is an example of combination reaction. Action of heat on ferrous sulfate crystals. Procedure: take some crystals of ferrous sulfate in a clean dry test tube. Heat the test tube strongly over a Bunsen burner for about 10 minutes. Note the color and odor of the gas evolved. Continue heating till the color of the contents in the test tube changes. Record your observations. Observations and inferences. Observations: the crystals are pale green in color. Inferences: ferrous sulfate is a pale green colored crystalline substance. Observations: the evolved hot gases are colorless but have a nasty pungent, suffocating odor like that of SO2 and SO3. Inferences: sulfur dioxide and sulfur trioxide gases are present. Observations: moist blue litmus paper exposed to the evolved gas first turns red and then gets bleached. Inferences: gases have acidic and bleaching properties. They are likely to be sulfur dioxide and sulfur trioxide. Observation: the color of the solid residue is reddish. Inferences: residue is ferric oxide in solid phase. Chemical equation: 2FeSO4 7H2O Fe2O3S plus SO2G plus SO3G plus 14H2OG. Conclusion: ferrous sulfate, on heating, decomposes to give a residue of ferric oxide along with a gaseous mixture of sulfur dioxide and sulfur trioxide and steam. Action of copper sulfate solution on iron nails. Procedure: take about 25 ml of from CuSO4 solution in a clean beaker and note the color of the solution. Take 3 to 4 rust-free iron nails. Note their color and then place them in the solution in the beaker for about 15 minutes. Then observe the changes in the color of the solution and the nails. Use a pair of forceps to remove the nails from the beaker. Wash them with water and place them on a filter paper to dry for about 15 minutes. Note the changes in the color, if any, in the nails. Record the observations and inferences. Observations. Before the experiment, copper sulfate solution, sky blue, unrusted iron nails, steel gray. After the experiment, copper sulfate solution, pale green, unrusted iron nails, reddish brown. Inferences. When iron is placed in a solution of copper sulfate, they react chemically. One of the product of the reaction, ferrous sulfate, is pale green in color and soluble in water. Chemical reaction. CuSO4 Aq plus FeS. FeSO4 Aq plus Cus. Conclusion. Iron displaces copper sulfate solution, indicating that iron is more reactive than copper. AB plus CD Cb plus A. This is an example of decomposition reaction. Reaction between sodium sulfate solution and barium chloride solution. Procedure. Take about 5 ml of sodium sulfate solution in a clean test tube and observe its color and appearance. Take about 2 to 3 ml of barium chloride solution in clean test tube and observe its color and appearance. Add contents of second test tube to that of the first one. Shake it without spilling the contents and place it in a test tube stand for about 5 to 10 minutes. Then observe the changes, if any, in it. Record the observations and inferences. Observations and inferences. Observations. Solution of sodium sulfate is colorless and transparent. Inferences. Sodium sulfate is a soluble compound, forming a colorless solution in water. Observation. Solution of barium chloride is colorless and transparent. Inferences. Barium chloride is a solution compound forming a colorless solution in water. Observation. The new substance obtained when barium chloride is added to sodium sulfate solution in a white, curdy precipitate in a colorless solution. Inferences. Barium chloride reacts with sodium sulfate, forming a curdy white, insoluble precipitate in a colorless, transparent solution. Conclusion. AB plus CD, AD plus CB. This is an example of double displacement reaction or a double decomposition reaction.